Hi guys, we're going to do a power video for Unit 2. I made a mistake earlier, so I'm just deleting my lines real quick. And let me just kind of discuss overall Unit 2. So in Unit 2, focus on two big issues. Describing an individual value's location within a distribution of data, and modeling distributions with density curves. Z-scores and percentiles provided easily calculated measures of positions for individuals. This leads me to interpreting a Z-score, finding and interpreting a Z-score, which I'm going to talk about in the next page. All right. Now, furthermore, with density curves come in assorted shapes, but all share the property that the area beneath the curve is 1. We can use area under density curves to estimate the proportion of individuals in a distribution whose values fall in a specified range. In the special case of a normally distributed data, we can use a standard normal curve in Table A to calculate such areas. There are many real-world examples of normal distributions. And when you meet a new set of data, you can use the graphical and numerical tools discussed in this chapter to assess the normality of the data. Okay, so let's start talking right away here about the cumulative relative frequency graph here. You just need to know how to read it. So you may be asked, what percentile is $60 in? Well, $60 is right here. You scroll up, you go over, and you can see that the percentile that $60 is in is about 85 to 87-ish%. That means if there was 100 people in the room, 87 people and less than that. So less than and equal to 87 spent $60. Excuse me, I fumbled over my words a little bit there. Okay, I'm going to take those lines off. Now I'm going to go and say, let's go the other way. Can you describe the distribution of the lowest 20% of people? I'm going to go over here, and I'm going to say the lowest 20% of people spent about $18. Another question I've seen is, what is the median of the data? 50% is the median of the data. Okay, now we're going to go down, and the median looks like it's approximately $28. Now you can see there's much more variation from $28 to $100 spent in the upper 50% than there is in the lower 50%. It is not as variable down here. So 50% of people spent between $0 and $28. That's the lower 58%. Not much spread there. $28 to $100 is the upper 50%. Okay, knowing how to read that. And the last questions I have seen with this is, what's the IQR? So I would go to 75%. I'd go down, and I'd see that that's approximately $48. That's quartile 3. Quartile 1 is the 25th percentile. So I go over, I go down, and I can see that that's about $18. So 48 minus 18, the IQR is about $30. All right. Speaking of outliers, it's important that you have the outlier rule memorized. I spoke about that a little bit already, but let me just put it down for you so you can get it down for your notes if you don't have it. The outlier rule is to determine the upper fence and the lower fence. The upper fence is equal to quartile 3 plus 1.5 times the IQR. IQR is quartile 3 minus quartile 1. The lower fence is quartile 1 minus 1.5 times the IQR. Okay, if they're above the fence, the data's above the fence, it's the upper outlier. If the data's below the fence, it's a lower outlier. Make sure you know how to do a box plot with this, with outliers. Okay, the next thing we're going to talk about is adding, subtracting, multiplying, or dividing a constant. What's going to happen to the shape, the center, and the spread? So here's my distribution right here. I have a distribution of test scores. Okay, the average is 10, standard deviation is 2, and median is 12. Quartile 1 is 5, quartile 3 is 8, and the minimum is 2. I don't like those scores. They're too low for me. So what am I going to do? What's going to happen to the distribution if I decide to multiply or add 5 to everything, to all the scores? I don't need to take the list of data, and I don't need to add 5 and rerun my one variable stats. I know that when I add 5, that's going to change the center, so the new mean will be 15. The standard deviation, though, the spread is not going to change when I'm adding or subtracting. The median, though, is going to go up by 5. That's 15. Quartile 1 is a measure of location. That's going to go up by 5 as well. That's 10. Quartile 3 will go up by 5. That's 12. And my minimum will go up by 5. That's 7. Okay, make sure you understand, again, adding or subtracting numbers to data is not going to change the shape. It will change the center by going up by 5 because I added 5 here, but it's not going to change the spread. The data just moved up the number line by 5 spaces. When I multiply, though, let's multiply by 2. That is going to change everything. The shape will stay the same, okay? The shape of the distribution will not change, but the center will be changed. That's 20. The standard deviation does change, so the measures of spread change when we multiply or divide. That's 4. The median would be 24, and the quartile 3 would be 16, and the minimum would be 4. Whoops. That one up there. It should have gone down here. Okay, we have a lot to get through in this unit. Again, this is not designed for me to reteach it to you. It's just for it to remind you. You should have your notes where you're going through this and be like, oh yeah, this should be making a sense. If it's not, then you need to mark it and come to me and say, I need an extra lesson on this. Okay, mean versus median. I talked about that in unit 1, talking about skewed versus symmetric and that outliers chase the tail. They chase the extreme observation, and that's why we use the median to describe a skewed distribution versus a mean for the symmetric. If you have any more questions, please let me know. Okay, and then finally, we need to talk about z-scores. You will be asked to interpret a z-score. To interpret a z-score, those are the exact standard deviations. So a z-score of 2.5 means that observation is 2.5 standard deviations above the mean. If you had a z-score of negative 1.37, negative 1.37 means that would be the exact standard deviations below the mean because it's a negative number. When you're figuring out, when you're using a z-score and you're trying to figure out a percentile that goes with it, or the chances for one observation to be there, I can give you exact examples if you need, but just remember when you were asked what's the probability of getting an ACT score, so I can even do it here for you. If I know that the average ACT score is SAT, let's say, is 500 in math with a standard deviation of 100. And Jill, she got a 650 on her SAT score. What percentile is she in? Okay, whenever you see the word normal distribution, think you're going to be finding a z-score. So we'd find our z-score, ZOMS, observation minus the mean divided by the standard deviation. When I do 650 minus 500 divided by 100, I get 1.5. That means Jill is 1.5 standard deviations above the mean. I can then go to my chart. I go to 1.5, and if it strictly asks for a percentile, that means this definition, less than, right here. Okay, so 1.5 means Jill is in the 0.9332. That's the proportion of people who are scoring as well as Jill or less than Jill. Otherwise, you could say she's in the 93rd or 93.32 percentile. But I like stating it more as Jill is right here. This is her z-score. You can imagine it here. The proportion of people that are scoring as well as Jill or less than Jill is 0.9332. So automatically, if you just see the word percentile, you're stopping at the table. If you see what proportion of people are scoring better than Jill, greater than Jill, you're doing 1 minus. If you get John's score as well, and you say what percentage of people score between John and Jill. John got, let's say, a 400. Okay? John's z-score then would be a -1. He's -1 z-scores or standard deviation below the mean. If I'm asked what proportion of people are scoring between John and Jill, I'm going to get John's percentile, I'm going to get Jill's percentile, and I'm going to subtract them. So that is the purpose of this. You get a z-score, you go to the table, you stop if it just says what proportion are less than or any kind of less than. You do 1 minus the p-value if you see a greater than. You do big minus small if they're asking the proportion of people between. You may have to work backwards and find a z-score. Joe is in the 90th percentile for test scores that have a mean of 20 and a standard deviation of 10. That's where you have to work backwards by doing what? You go and you find the 90th percentile, so 0.9. 0.9 is approximately right here, okay? 89.97%. That's the closest to 0.9 you can get. You go and you follow, and that's going to give me 1.208, okay? So that means Joe, by going backwards, had a z-score of approximately 1.28. Well, then I'm going to put that into my z-score formula. 1.28 equals my observation minus my mean of 20 divided by my standard deviation of 10. Zums. I'm going to solve for my observation, and that's going to give me Joe's z-score. And that's all I have for you guys. A quick review on Unit 2. I hope that helped bring some stuff back. I hope you're writing stuff down if you're not getting it. If I'm talking too fast, I'm sorry. This is not meant to teach you. It's meant to just quick review with you. Have a great day.